Assalamualaikum warahmatullahi wabarakatuh, and every good day to everybody. So now we move to our new chapter number 4, moments and couples. Okay, basically when talking about moment, we need to put the moment of force. Okay, moment of force is actually about an axis point through point O. For short, is the product of the magnitude of the forces and the perpendicular distance between point O and the line of action of force F. So meaning that if we want to define what is the moment of force, moment of forces about an axis through point O. For example, this point O, for example, is actually the product of the magnitude of the force and also the perpendicular distance. So this force is the line of action. This one is the line of axis D. So this line and also this force must be perpendicular each other. So meaning that the force multiplied by the perpendicular distance. So force and distance must be perpendicular. So M is equal to Fd. So the unit of moment is a Newton dot meter in the SI unit. And M is magnitude of the force of F around point O, and D is a perpendicular distance from point O to line of action of F. Okay, for example, we are talking about the moment in 2D. So direction of moment is given by right hand rule. So meaning that is a counterclockwise. If the force the direction is here, this one is about O. So we want to rotate the force about point O. So this one counterclockwise. So counterclockwise is actually out of the pitch, because this one is a counter, and then this one your thumb is out of the pitch. Okay, but is the clockwise is opposite, and this one is the direction of the force in the here. So we want to about O, so we want to rotate about O, so it's a clockwise, so into the pitch. Okay, so moving a force along its line of action, because this one is a force, this one is a point O. Now because moving a force along its action result in a new force system which equivalent to the original force system. Okay, so as I said before, the definition of the moment of force is actually the force and also the distance must be perpendicular each other. So here, what we have here, so the force here at this point, but from point O to this point, for example, we have the position R vector here. The R is the distance from point O to this point of force. Okay, so now how I want to get the moment about this force rotate about point O. So what we have here, so it's actually force multiplied by a distance, okay, so but we have only the data R, so we have the F. So how you want to relate? We cannot simply multiply the F and R, because this one's F is also not a perpendicular distance with this R. So we need to find the perpendicular distance. That this is actually line of action. Okay. So now we want to find the perpendicular distance to the line of action. So we have the D here. You see D here. This runs a line of axis. Line of axis here should be perpendicular to this line of action. So we need to find this distance by using the angle theta here and also R. So define here, this one, the R multiplied by sine theta, you get this D. So D multiplied by F. So we have the FR sine theta. Okay, same thing here. If you want to using this R, you need to find this F tangent here. You can see here perpendicular F here. You need to find this F. If you can get this F by using this angle. For example, this one is the F sine theta. So F sine theta, the moment, if you are using R instead of D, R multiplied by F multiplied by sine theta, because we need to find this magnitude of the F here, this line, because this line is perpendicular with this R. So this F prime, for example, multiplied by this R. Okay, so we have an example here. Calculate the magnitude of the moment about the base point O of 600 Newton in 5 different ways. It's actually many different ways. different ways. So I give you two, and then you need to think of about another method. Okay, another different. Okay, so here for the first one, so 600 Newton through the to the point O. So we need to find the perpendicular distance from O to A. So O to this line. This one is a line of force. We need to find the perpendicular distance, line of the axis. Okay, so O from these forces, this one is a D. So you can find this D. So the 600 multiplied by this D. Okay, you cannot simply multiply by 4. You must multiply by this D. From here to here is the perpendicular distance to the 600 Newton. So the moment arm of 600 Newton. D, how to find D? So we need to find this theta. So this one is a tan theta, sin theta. You get this distance. So this one a cos theta. You can get this distance. So you can see here 4 cos 40 plus 2 sin 40. Say 4 multiplied by cos 40, you get this from here to here. 2 multiplied by sin 40, you get from here to here. Okay, this why you get the 4 cos 40 plus 2 sin 30, you get 4.35. So the F is a 600 multiplied by this D. So F is a 600 multiplied by D is a 4.35. So you get a 2610 Newton dot meter. Okay, whereby if you want to use 4 meter, so how you want to utilize this 4 meter? You can resolve this 600 into this line of action, new line of action here. So you can find here 600 multiplied by cos 40, then we can simply multiply by 4. Okay, you can see here, replace the force at the angular component A. So F1 is the 600 cos 40. So 600 cos 40, you resolve. Because you are resolving into the X, now it should be resolved to Y, because the force is a vector. So this one is the n angle. So we have the component X, component Y. So the component of X, component of Y. So F1 is the component of X, F2 is component of Y. So component of X multiplied by a perpendicular distance, this one 4. Component of Y multiplied by perpendicular distance, this one 2. So we have the 600 cos 40 and the 600 sin 40. So you sum up, so you get the total moment is equal to this one, the force multiplied by distance. So force multiplied by distance, so we have the 2610. So same answer, although a different way. So there are many different way. So you must understand the concept. The force must be perpendicular with distance. Okay, now we move to the moment of couple. A couple can be defined as two parallel forces. We have this force 1 and force 2 here. Okay, having the same magnitude, this force and also this force the same magnitude, but the only is the difference is the opposite direction. They have a separate the opposite direction. The force is giving for this direction, another force is giving direction the opposite direction, the same magnitude and separated by a perpendicular distance. So this one is just separate by perpendicular distance each other. So this one, how to say that, this one is a parallel force. So moment of couple is a two parallel forces having a same magnitude by the different opposite direction separated by a perpendicular distance d. So the moment of couple is the product of magnitude. So how to find the moment of couple? So magnitude of the forces and then perpendicular distance with their line. We just simply multiply the force and also the d. Okay, so the couple means two parallel force, same magnitude but opposite direction, separated by perpendicular distance d. So resultant force equal to 0 because this one positive, for example this one positive, this one negative, so total resultant force and also this one negative as becomes 0. So tendency to rotate in specified direction, for example, so you rotate here, this one rotate back here, so this one specified the direction. So couple moments, the sum of moments of both couple forces about any arbitrary point. Okay, so this one's a scalar formulation. So this F just multiplied by a D, so you get the moment of couple. So direction and sense are determined by right hand rule. So you can simply, this one is a force, this one force 1, the positive force, and then also negative force. So direction is upward. So M is perpendicular to the plane. The direction of moment is perpendicular to the plane containing the forces. Okay, we have here equivalent couple. So two couples are equivalent. Two couples are equivalent if they produce the same moment. Okay, force of equal couples lie on the same plane or plane parallel to another. So we have here, for example, two couple equivalent if they produce the same moment. For example, here 30 multiplied by 0.4 also same the 40 multiplied by 0.3. So although the magnitude of the force is different, 30 and 40, but when you multiply the force with the distance, separated distance d here, so you can result the same magnitude of moment. So this one's two couples are equivalent if they produce same moment. So force of equal couple lie on the same plane or plane parallel to one another. Okay, I think we stop here. We move later. We will continue in the example of moment of couple, and then the rest of the chapter of moment and couple. Okay, thank you. See you in next class. See you in next session. Bye bye.